Welcome back to today's class on quadrilaterals. In the previous classes, we learned what are triangles, are three-sided polygons, and now we are going to discuss about the four-sided polygons that are quadrilaterals. My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So first of all, let's try to see what is a quadrilateral, which type of shapes or which type of figures we consider as a quadrilateral. Okay, you can see here. A quadrilateral is a simple closed figure, simply polygon. Okay, simple closed figure, we say that is a polygon. If you can remember the definition of polygon, a simple closed figure, right? Bounded by four line segments in a plane. How many? Four line segments. And now here you need to understand the difference between different polygons. In the previous classes, we discussed about triangle, which is a three-sided polygon, 1, 2, 3, which is surrounded or bounded by three line segments. And now we're discussing about a polygon with a four-sided. Polygon with a four-sided, right? So how to structure that? How that quadrilateral will look like? So we have different structures. Triangle, we always have a triangle in this way, okay? Based on the side lengths or whatever it is, we say isosceles triangle, equilateral triangle, scalene triangle. And based on the angles also, we keep different names for that, right? Equilateral triangle and obtuse, acute angle, right angle triangle. So different names for that. In the same way, based on the different properties the sides have or the angles have, we name them into different structures. Although all these figures are again a closed figures of four segments by four line segments. Okay, so you can see here, if let's say all the sides are equal in this figure, if all the sides are in figure, so we say that square. If only opposite sides are equal, we say that as a parallelogram, right? And again, opposite sides are parallel, opposites are parallel, and these two sides are equal. These two sides are equal. So based on the different orientation, different properties that sides exhibits or the angles exhibits, we keep different names for them. And again, whenever we see different figures, sometimes all the sides of that figure may be equal, sometimes may not be. All the angles may be equal, sometimes may not be. Sometimes only opposite angles may be equal, opposite sides are equal. Sometimes nothing will be equal. No side, no angle, nothing will be equal. So based on that, we have different quadrilaterals. Okay, let's try to understand one after that in today's class. We're going to learn what are the different types of quadrilaterals that we are having. Okay, so the first one we're going to discuss about a rectangle. This shape, whatever you're seeing here, okay, the quadrilateral ABCD has four sides. First of all, let's try to understand about some terminology of this quadrilateral. Quadrilateral means a four-sided closed structure or four-sided polygon. The quadrilateral ABCD has four sides, AB, BC, CD and EA. AB, BC, CD and EA. So we have four sides. These four sides are common for all the quadrilaterals. If a quadrilateral is not having four sides, it is not a quadrilateral, it is some other figure. If it is having three sides, we say triangle. 5 sides, pentagon, 6 sides, hexagon. So we have different names for all those. Okay. So now, the quadrilateral ABCD has four sides, AB, BC, CD and EA. AB, BC, CD and EA, and four vertices. What do you mean by vertices? That exact corner points. This corner point, which we write it as A, this is B, this is C, and this is D. These are the four vertices. These are the four vertices. So a quadrilateral will have four sides, four vertices, and also if you can observe, there is an angle here, there is an angle here, there is an angle here, right? Whatever the angle it is, so we have four angles as well. So for a quadrilateral, we have four sides, correct? Four vertices, again that's correct, as well as four angles, So all these will be in count of four for a quadrilateral. Angle, this is how we represent angle, right? So this is angle A. The measurement here that we obtained is angle B. How to measure the angles, how to write them, that we are going to learn later. Okay, so these are the four angles. Angle A, angle B, angle C and angle D are the four angles formed at the vertices. Angles will form at the vertex. Okay, so we have four vertices, four sides, four angles, and that type of structure we say it is a quadrilateral. Okay, so the next one, when we join the opposite vertices AC and BD. So this is a quadrilateral, you know that. Now I want to join A and C. So we get one line segment here. Let me draw that once again properly. So now we are joining A and C, not A and B, A and C, as well as B and D. So what is this BD? What is this AC called? AC line and AC line segment and BD line segments are called diagonals of a quadrilateral. Okay, so AC and BD are the two diagonals of the quadrilateral ABCD. Now the question is, for a quadrilateral, how many diagonals are possible? For a quadrilateral, 1, 2, 3, 4. No, only two. Which two? AC and BD. AC or CA, both the same. Again, no need to write it as two different diagonals. They are line segments. So again, BD or DA, again that is a line segment. So total we have two line segments. Total we have two line segments, two diagonals. So in a quadrilateral, when we said four sides, four vertices, four angles, but not four diagonals, we only have two diagonals. And again, based on the properties the diagonals exhibit, whether they are equal or not, whether they bisect. Bisect means they divide them into two equal parts, both the diagonals. Okay, so based on that also we define a lot of quadrilaterals. Okay, let's try to understand more about this one. Sum of four angles of a quadrilateral 360 or four right angles. Okay, this is always correct. Sum of four angles of a quadrilateral. So what are the four angles here? A, B, C, right? So angle A plus angle B plus angle C plus angle D. Sum of all these angles is 360 degrees. Sum of all these angles is 360 degrees or four right angle. What do you mean by right angle? I told you in last class, four right angles, 4 and 90 degrees, which is again equal to 360 degrees. One right angle is 90 degrees. One right angle is 90 degrees. Okay, so sum of four angles of a quadrilateral 3 is 360 degrees or four right angles. Okay, next one. So let's try to understand different types of quadrilaterals. As I told you, depending on the structures, depending on the size, depending on the length of sides or the angles, we have different structures. The very first one you can see here. Okay, so what happened here? These two sides are parallel. That means out of all the four sides, one pair or two sides are parallel. Two sides are parallel. AB is parallel to CD. This is a symbol for parallel. Parallel in the sense they are moving in the same direction. Okay. And what about AD and BC? AD and BC are not moving in the same direction, but they are equal in length. Okay. So if AD and BC, AD is equal to BC, then we can say that it is a trapezium. This is called a trapezium. Okay, the quadrilateral ABCD had one pair of opposite sides AB and DC, had one pair of opposite sides, right? One pair of opposite AB and CD parallel to each other. Such a quadrilateral is called trapezium. Such a quadrilateral is called trapezium. If these two sides are parallel, it is enough to say that it is a trapezium. But what happens if the sides are also equal? If the sides are also equal, if in a trapezium non-parallel sides are equal, so if these two sides are equal, whatever I'm saying here, if AD is equal to BC, then still it is a trapezium, but it is an isosceles trapezium. Okay, we say that as isosceles trapezium. When two sides are parallel, it is enough to say that it is a trapezium. How to read that? It is a trapezium. But in that trapezium, if the lines which are not parallel, these two lines, if they are equal in length, we can say that it is a trapezium. You can ask me, sir, always do we have AD and BC equal? Not always. You can have a trapezium like this. I'll draw here only. So this one side. Okay. So you can see here, these two opposite, this one and this one are not equal. Although these two are parallel, the other two sides are not equal. So it is just enough to define a trapezium if one pair of sides are parallel. But if the other two sides are equal, then we can say that it is an isosceles trapezium. We can say that it is an isosceles trapezium. Okay. So moving ahead for the next question. So yeah. So once again, trapezium. Let me draw trapezium like this. So this trapezium, which we are not going to discuss now. Now there is some difference between these two. What happened? Here, not only one pair are parallel, the complete, all the sides are parallel, right? All the opposite pairs, these two are parallel as well as these two are parallel. And obviously when these two are parallel, we say that it is a parallelogram. We say that is a parallelogram. If both pairs of opposite sides, if both pairs of opposite sides of the quadrilateral are parallel, such a quadrilateral is called a parallelogram. If both pairs of opposite sides of the quadrilateral are parallel, such a quadrilateral is called a parallelogram. So here AB, this side length, is parallel to CD. AB is parallel to CD in the same way BC is parallel to AD. BC is parallel to AD. AB is parallel to CD and BC is parallel to AD. If both pairs of opposite sides of the quadrilateral are parallel, such a quadrilateral is called a parallelogram. Okay, so what else we are going to learn in the next one? So here carefully see that. Once again, let me draw the previous two figures. One, we discussed about trapezium. Right? This is a trapezium. The next one we discussed just now about a parallelogram. Just now we discussed about parallelogram. Okay, so this is a parallelogram. The next we are going to discuss where although both the sides are parallel, but some other things are there to discuss here. What is that? Parallelogram having all its angles as right angles. You know what is right angle? A perfect L-shaped. A perfect L-shaped will give you right angle, right? So this is not an L-shape. This is not an L-shape. Not L-shape. Not L-shape. So parallelogram will not have right angles. But in case if that parallelogram has right angles, in case that the parallelogram has right angles, we say that as a rectangle. We say that's a rectangle. This is one right angle, right angle, right angle, and right angle. So all its angles as right angles, we say that as a rectangle. Understand? Parallelogram having all its angles as right angles is rectangle. Opposite sides are equal in a rectangle. Okay, opposite sides, that means AB and CD are equal. AB and CD are equal, and BC and AD are equal. BC and AD are equal. Okay, so this is how we try to define rectangle. We discussed about trapezium where one side is parallel, both opposite sides are parallel. We say parallelogram. Opposites are parallel and it is a right angles. We are getting right angles. It is called rectangle. Still, there are more quadrilaterals that we are going to discuss in today's class. The next one is something like a diamond shape, you can say, which is called a rhombus. Okay, parallelogram having its edges and sides equal. Edges and sides, that means edges and sides are equal. The next to next sides are equal is called a rhombus. Okay, so edges and these two sides are equal. These two sides are equal. So then we can say that it is a rhombus. Edges and not all the sides. Not all the sides, that we are going to discuss next. What will happen when all the sides are equal? So it is a rhombus. Okay, so now let's come to that. Parallelogram has its edges and sides equal and angles of 90 degrees. Edges and sides equal and angles of 90 degrees, right? So this is called a square. So this is right angle, right angle, right angle, right angle, and all the sides are equal. All the sides are equal. Then we can say that it is a square. What is the difference between the before case? In the before case, when we're discussing about a rhombus, right? Here also all the sides are equal, but the angles are not equal to 90 degrees. Whereas in the next structure, when we're discussing about a square, right? Let me go back to square, right? When we're discussing about square, edges and sides are equal and angles of 90 degrees. So all the angles are 90 degrees. This is called as a square. All the sides are equal. In a square, AB is equal to BC is equal to CD is equal to DA. All the sides are equal. And all the angles are 90 degrees. This is very important because that point is not correct for a rhombus, but for a square it is correct. Understand? That is the difference between rhombus and square. Next one. Parallelogram has its edges and sides equal and angles of 90 degrees. The same square. Okay, once again the slide got repeated. Next one. So now I think you can see this shape, which is something like a kite shape. Okay, you know what is a kite, right? So kite, K-I-T, kite shape diagram. Again, it's a four-sided closed structure, which is a polygon, which is a quadrilateral. The quadrilateral ABCD having two pairs of edges and sides equal. Two pairs of edges and sides equal. That means this one and this one are equal. This one and this one are equal. Where AB is equal to A, B is equal to AD, and BC is equal to CD. This is called a kite. Okay. So this type of structure is called kite. You know what is a kite, right? So once again, let us try to come back for all the diagrams that we have discussed now. We discussed what is a trapezium. We discussed what is a trapezium, where one side are parallel. Opposite sides are parallel. We say it is a parallelogram. We say that is a parallelogram. From there, we also got a rectangle where angles are 90 degrees, rectangle, but not all the sides are equal in rectangle. When all the sides are equal, and all the angles are 90 degrees, we say that is a square. Okay, and this shape, diamond shape, where adjacent sides are equal but not 90 degrees, we say that as a rhombus. And again, from rhombus, now we are discussing about kite shape. Okay, so these are all the different quadrilaterals that we are learning in this chapter. Right. Next one, ABCD is a parallelogram and angle A is equal to 60 degrees. So find the remaining sides. What is this? What is ABCD? ABCD is a parallelogram. Angle A, this value is given as 60 degrees. Angle A is given as 60 degrees. The question is, find the remaining angles. So how to find this one? We need to find the remaining angles. Can you carefully observe? In a quadrilateral, the very first one you need to understand is sum of the edges and sides is 180. Sum of the edges and sides, that means angle A plus angle B should be 180 degrees. Sum of the edges and sides should be equal. I mean, sum of the adjacent angles should be 180 degrees. 180 degrees. Okay. So 60 plus angle B is 180. So angle B is equal to 180 minus 60, which is a 120. Angle C is 120. Angle B, once again, it's angle B, right? Angle B is 120. In the same way as we have discussed now, if you consider that adjacent angle is D, right? So these two should be again 180. So this is again 120. And again 120 plus some number should be 180. So again it is a 60. So in a parallelogram, if you have one side is 60, one angle is 60, the other angle will be 120, the other angle is 60 again, the other angle is 120 again. This is how the pattern will look like. Okay. Let's go for one more approach of the same concept. Two adjacent sides of a parallelogram are 4.5 centimeters and 3 centimeters. So find its perimeter. What is that happening here? Two adjacent sides of a parallelogram are 4.5 and 3 centimeters. Carefully see here. 4.5 parallelogram. One is 4.5 centimeters, other is 3 centimeters. Now, the question is to find its perimeter. What do you mean by perimeter? Perimeter is the sum of all the sides. How many number of sides it may be? It may have 10 sides, 20 sides, 100 sides, whatever it is. Sum of all the lengths of all those sides will give you perimeter. We are not discussing about area. Don't forget or don't confuse between perimeter and area. Right? So now one side is 4.5, other side is 3 centimeters. Again, these two are equal. I said in parallelogram, these two will be equal. So this again 4.5 centimeters and this is again 3 centimeters. That is again 3 centimeters. Okay. So now let's try to find the perimeter, which is a 4.5 plus 3 plus 4.5 and again plus 3. 4.5 plus 3 is 7.5. 7.5 plus 7.5 will give you 15 perimeters, 15 centimeters. Okay, so 4.5 9 plus 3 12 plus 3 15. So that is the perimeter of this parallelogram. Perimeter means always sum of all the sides. Perimeter means sum of all the sides. Right. What else we are having? Next one. Two adjacent sides of a parallelogram are 4.5 and 3 centimeters. Find its perimeter. The same question again. Okay, the same question again. The next one. Okay, let's try to discuss once again about all the quadrilaterals that we have discussed in today's class. So, what the first one that we are going to discuss is a trapezium. We have discussed about trapezium. Once again, let me write all this trapezium, where if you can remember, only one pair of opposite sides are equal or parallel. So, not equal, parallel. One pair of opposite sides are parallel. Let me name that ABCD. So we can say that AB is equal to CD. We can say that AB is equal to CD, right? In the same way, we have parallelogram. We have parallelogram where these two sides are parallel as well as these two sides are parallel and they are equal. I mean, these two opposite sides are equal, these two opposite sides are equal. So ABCD, we can say that AB will be equal to CD and BC will be equal to AD, right? And from the parallelogram only, where two sides are, the opposite sides are parallel, we came to conclusion of what is rectangle, what is a square, what is a rhombus, what is a kite, right? So all this came from the basic structure called parallelogram, right? So coming to that and more in detail specifications as well as properties of all these quadrilaterals that we're going to cover in the next class, right? So I hope you enjoyed this lecture about all the quadrilaterals. In the coming class, we're going to discuss some more applications based on all this, right? Thank you so much, students. Stay tuned to get the next lecture. Thank you.